Alright everyone, so this is the second video on division of polynomials, and I've just set up 3 examples here that I'm going to go through. So we'll just get stuck into it, we'll work through them, and hopefully by the end of it you'll be seeing the pattern in these questions. The first one I've done works out really nicely, it won't have a remainder. The second one will have a remainder, and so you'll see how that's written. And then the third one is going to be dividing by a non-linear factor. So we'll just see how these go. To begin with, we're doing x cubed plus 12x squared plus 39x plus 28 divided by x plus 1. So I'll write the x plus 1 out the front, and then I'll write the x cubed plus 12x squared plus 39x plus 28 in here. So same process as we saw before, we ask ourselves how many x's go into x cubed, and the answer is x squared. Now that I multiply the x squared by the x plus 1, and again I'm going to do that just off on the side, which that gives x cubed plus x squared, so I'll write that down here. And that's what we take away. Now when we take that away, x cubed minus x cubed is not going to leave anything. 12x squared minus x squared leaves 11x squared. The other two terms, the 39x and the 28, have not had anything done to them, so they will just continue down here. Alright, so the next thing we do is ask how many x's there are in 11x squared, and the correct answer there is, well, 11x. So, over on the side here, I'll do 11x multiplied by the x plus 1, which leaves 11x squared plus 11x. And I'll write that down here to then take it away. (11x squared minus 11x squared is nothing. 39x minus 11x leaves 28x. And I've still got a 28 there, which didn't have anything done to it, so it gets brought down to this next line. The last thing is to ask how many x's there are in 28x. And the answer to that is, well, there are 28 of them. So on the side, I'll do 28 times the x plus 1, which leaves us with 28x plus 28. And I'll write that down here to then take it away. 28x minus 28x is nothing. 28 minus 28 is also nothing. So we've been left with a remainder of 0. And therefore, we can say, remember that this is our answer up here. So when we do x cubed plus 12x squared plus 39x plus 28, all divided by x plus 1, we are left with x squared plus 11x plus 28. You might remember the last video I was talking about, that there were 5 4s in 20, for example. So here we can say that there are x squared plus 11x plus 28 x plus 1s in x cubed plus 12x squared plus 39x plus 28. Not quite as nice as those last ones we were doing. Let's move on to the next one. Divide 4x cubed plus 4x minus 11 by x plus 2. The thing that's slightly different about this polynomial is it's missing an x squared term. Now, when it's missing a term like that, it's a really good idea to write the term in anyway. So when I write this question out, I'm going to write the x plus 2 out the front. And then under here, I'm going to write 4x cubed plus 0x squared plus 4x minus 11. And we'll work through the same process. How many x's are there in 4x cubed? Well, there are 4x squared of them. Write the 4x squared out the front. Then we'll write the x plus 2 here and expand it out. So that leaves us with 4x cubed plus 8x squared. We'll write those down here and take them away. So 4x cubed take away 4x cubed is nothing. 0x squared take away 8x squared is negative 8x squared. And the other two terms have not had anything done to them, so we'll bring them down. We'll ask ourselves how many x's in negative 8x squared. So there's going to be negative 8x of them. And over here I'll write negative 8x out the front of x plus 2. And that leaves us with negative 8x squared minus 16x. Which we'll take away. Negative 8x squared minus negative 8x squared leaves nothing because the minus negative makes it a plus. 4x minus negative 16x also becomes a plus, but it's going to be 20x, and we've still got a minus 11. The last step is to ask how many x's there are in 20x, which there are 20. So put the 20 out the front. X plus 2 leaves us with 20x plus 40. Write that down here. Take it away. And so 20x take away 20x leaves nothing, but negative 11 minus 40 leaves negative 51. Therefore, we have a remainder of negative 51. And you can see I can't take this any further because if I say how many x is going to negative 51, well, that starts to get pretty messy, right? So what we do is we say, well, when we have 4x cubed plus 4x minus 11 divided by x plus 2, that's equal to 4x squared minus 8x plus 20. So again, that's this line up here. But I also have a remainder of negative 51. And the way that we write a remainder, you might remember from the 478 divided by 19, that I think it had a remainder of 3/19. Okay, so the way that we write that is the remainder over the thing that's being divided by. And so this is going to be minus 51 over x plus 2. The last example, which you can already see on screen, divide x cubed plus 5x squared minus 9x plus 4 by x squared minus 1. So this is a non-linear term or equation term. What am I looking for? Expression, that's the one that we are dividing by. So write the x squared minus 1 out the front, and then the x cubed plus 5x squared minus 9x plus 4. So we ask how many x squareds go into x cubed, and the answer is x. So over here I'm going to do x times x squared minus 1, which leaves x cubed minus x. Okay, so we're going to subtract that. I'll write them down here. What I'm going to do is I'm going to line them up with the corresponding term. So I've got the x cubed there lining up with the x cubed. I'm going to put the minus x over here so that it lines up with the x term. So x cubed minus x cubed is nothing. We've got 5x squared, which we're not taking anything away from, so that 5x squared is just going to still be there. We've got minus 9x minus negative x, so minus negative makes it plus, and that leaves us with minus 8x. And then the plus 4 has also had nothing subtracted from it. Then we ask ourselves, how many x squareds go into 5x squared? And the answer there is 5. So 5 times x squared minus 1 is 5x squared minus 5. Write it down here. Again, lining it up with the corresponding terms. 5x squared minus 5x squared is nothing. Negative 8x minus nothing is going to be negative 8x. And then 4 minus negative 5 makes plus 9. Now we can't take this any further because if we say how many x squareds go into negative 8x, again that's going to be really messy. So this is our remainder down here now. And so therefore, if I do x cubed plus 5x squared minus 9x plus 4 divided by x squared minus 1, then that's going to be equal to x plus 5, and then minus, and I have to be a little bit careful here because I've got minus 8x, and I need to actually make this a minus 9 now, over x squared minus 1. And that's because if I were to expand this fraction, the minus applies to the 8x, which makes it a minus 8x. But if I do minus of minus 9, that gives the plus 9 that we see right here. Okay, so just be really careful if you have a negative term in the remainder there when you're doing these questions. The last thing is that we can do these on the calculator. So I'll just bring that up here. Put it on screen so you can see it. Okay, the way that we do these questions, honestly, any of them, let's go back up to do this one here. So if I want to figure out what this is, what I can do is I can write the equation in. So I'll just use a fraction template. 4x cubed plus 4x minus 11 over x plus 2. Now, if I just hit execute, it won't actually do anything. It just displays it exactly the same as it would otherwise. So what I'll do then is I'll highlight the thing that I typed in, go to interactive, and I want to transform it. I just want to get the equation in a different form. I go to fraction, and then prop frac. Okay, and that converts it. So you can see that we've got 4x squared minus 8x plus 20. So we've got this part here. You can see there's a slightly different order though with the remainder right here. So just recognize that when you see that part that's a fraction like that, that is the remainder. Okay, it's just the way that the calculator displays it, but you can always write it in the way that we did, which is just this answer right here. I think that's the more conventional way of writing it. So I'm going to leave the video there. If you have any questions about this, you can talk to myself or your regular classroom teacher, and see you for the next one.